Okay, so you've had a little bit of time now. Figured out the total value was 80. Again, 20% here, 20% here, 20% here, and 40% here. 20% of 80 is 16, 16, 16, and 32. So those are what we should have had. Now, step one is, again, our population, our Skittles bags, and it'll probably be what size Skittle bags they are. And our parameter is, are the bags correctly distributed? Do the bags that we have, are they correctly distributed? Are the bags correctly distributed? So that's step one. Step two, oh, I'm sorry, also for step one, we need our ho and ha. Step one would also be ho and ha. Step one, ho, the bags are correctly distributed. And ha, the bags are not correctly distributed. If you haven't done so yet, copy these values down, because we're going to need these in our calculator. If you want to put them right into your calculator, that's fine. Now, in the interest of time, let's talk about step two here. I'm going to move this over a little bit. I'll put step two right over here. Step two, simple random sample. Our expected values, are they all greater than or equal to 5? 32, 16, 16, 16. So check and a yes. And we're going to do a chi-squared goodness of fit. We're going to see how well our data fits the population. Chi-squared goodness of fit test. Now, we can put our data right into the calculator. Here's what I want you to do. I want you to put your data in the calculator. We can put this in L1, put this in L2. Figure out again for L3, it'll be the quantity of L1 minus L2, the quantity squared divided by L2. Figure out your chi-squared test statistic. Degree of freedom will be 3, and go from there. Again, I'll give you a minute. We'll come back together. We'll see if your answers match up to my answers. Okay, giving you a little bit of time here. I wanted to show you another way to do this problem. I have as you can see, I have the data in the calculator, and I have my L3 data in here. I want to show you another way to do that instead of using the second list. Well, just to show you here what I could do again, just real quick. I could go to math. Let me go to a blank screen, actually. I can go to second list math, and I can go again 5 sum of list 3. That's one way to do it. And as you can see, I get a chi-squared statistic of 8. Or I could just to show you another way to do it, calculate one variable stat of list 3. And again, you can see it even tells you here it's 8. Either one works fine. But what's more important is that you know what you're doing. Step 3, you need to write this. Chi-squared equals O minus E over E, the top is squared. O minus E, the quantity squared over E. And you just came up with an answer of 8. The degree of freedom will be, it was 4 minus 1 is 3. So, using your chart, I'm going down to 3. The first number I see is 4.11. Going across, I find 8 is in between 7.81 and 9.35. So my p-value is in between 0.05 and 0.025. If we compare that to alpha equaling 0.05, we can say p is less than alpha, so we will reject ho, and we can say in step 4 since P is between 0.025 and 0.05, then P is less than alpha, and you can like write 0.05, and we reject toe and say the bag is not correctly distributed. So again, I just gave you two more problems that we completely did using the four-step inference toolbox. Again, step 1, population and parameter, ho and ha. Step 2, SRS, expected values, greater than or equal to 5. Chi-squared goodness of fit test. Step 3, you need to show this. This is a big one. You need to show this formula. It's at the bottom of page 5. Got this from the calculator. Compare P to an alpha value. If they give you one, use it. If they don't, use 0.05. Step 4, tighten it all up. Now, last one I want to do with goodness of fit is the one that you did for me. And this is this one here, 13.1. Now, if you didn't realize this, for this problem here, let me make it just a little bit bigger so we can all see it. Here's what we have. First things first, this was the distribution of scores. This is your expected. If you didn't know this, this is expected, and this is observed. With that said, we're going to carry out the four-step inference. We're going to do a four-step inference toolbox for a chi-squared goodness of fit test. Now, you'll notice here, we're doing a test to see if our distribution is the same as the distribution. That's a tell. That's a tell saying use a chi-squared goodness of fit. Put these scores down here, the frequencies in L1. Put these frequencies in L2. Don't forget to do your 4 steps. We'll come back together in a couple moments.